Did you know that each kidney is composed of about 1,000,000 subunits called nephrons, and each nephron produces urine from start to finish, and as such, if we understand one nephron, we can understand the whole kidney. First, let's look at the gross anatomy. The kidneys filter our blood. They have a large blood supply to do so. In other words, when we say filter the blood, they remove impurities of the blood and they adjust the water volume. So our gross anatomy. Each kidney is covered with a renal capsule. Renal is the root or the Latin word that means kidney. So we have a renal capsule, then we have the renal cortex, which is composed of a granular looking material. Then you can see we have renal pyramids, and they do look like pyramids and they are shaped like pyramids. The tip of each pyramid is called the renal papilla, and urine is produced at each renal papilla. The urine is picked up by a branched funnel, and that branched funnel begins with minor calyces. Each one is a minor calyx. Remember, the calyx is the part that holds a flower up. Can you kind of see the flower, the bud appearance, and that would be the calyx. That's why it has the name minor calyx. Then 2 or 3 minor calyces form together a wider part of the funnel called a major calyx. Here's a major calyx. This is a major calyx. Then all of the major calyces form the renal pelvis. Pelvis means basin. This is where kidney stones can get stuck. In fact, sometimes they actually will have a jagged appearance because the crystal formation goes up into the calyces. The renal pelvis then narrows into the ureter and exits from the hilum of the kidney, the little indentation that you see there. The blood supply, it's quite vascular, the kidney's blood supply. Here's the renal artery, and the renal artery breaks into segmental arteries, which break into interlobar arteries, which form arcuate arteries, and which form interlobular arteries. The venous situation is the same. The venous blood comes back via interlobular veins, to arcuate veins, to interlobar veins, to segmental veins, to the renal vein. Now, what you see here in white is one of the 1,000,000 nephrons. The nephron is the functional unit of the kidney. And for now, we'll just get an overview. We can see it originates from these little balls called renal corpuscles, and then a tiny tube goes down, forms a hairpin, comes back up, goes down all the way down to the renal papilla. In the process, the tubule creates urine out of the original filtrate that enters the tubule. To understand the nephron well, we need to look at its structure, and the middle of this board will show the anatomy. Now, to get your bearings and understand a nephron, first let me show you where you are. This is the renal cortex. The cortical material looks grainy because it contains many, many renal corpuscles, which are the first part of the nephron that produces urine. This is the renal medulla, that is the middle, and this in fact is part of the renal pyramid. The renal pyramids are in the deeper part, the medulla of the kidney. The arcuate artery and vein, which form the division between the cortex and medulla, would be going crosswise here, and we have the interlobular artery and vein. Let's go back and get our bearings on our first one. Renal cortex, arcuate arteries and veins, renal medulla with the renal pyramids. So there we are. Have you ever considered how you clean a desk drawer? You can clean it 2 ways. You can pick out all the bad stuff, and that may take hours, or you can get a newspaper, dump everything, and bring back the good stuff. That's more efficient, and as you can guess, the kidneys do it the more efficient way. The nephron begins with a renal corpuscle that is very vascular. It has what's called a glomerulus, a tuft of little capillaries in it, and it's a filter bed that kind of dumps the good and the bad. It's certainly not urine that's dumped here. It's a clear fluid called filtrate that ultimately will become urine. But that filtrate has amino acids and glucose as well as waste, and it enters the proximal convoluted tubule where the good things, amino acids, vitamins, minerals, and glucose, are reabsorbed into the peritubular capillaries that you see drawn in this part. Well, that filtrate moves from the proximal convoluted tubule downward in the descending limb of the loop of Henle. This is the thin segment of the loop of Henle, the ascending limb of the loop of Henle. The ascending limb continues and becomes the distal convoluted tubule. In the loop of Henle, the water volume is adjusted. Now, if we need to save water, water will be reabsorbed into the vasa recta capillaries that you see here. If we've overdrunk and need to get rid of water, then less water will be reabsorbed and more water will stay in the tubule and will ultimately become urine. We're back up here again, and we enter the lighter colored, in this illustration, in this model, the lighter colored collecting duct, which will take what ultimately will become urine down, 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 and we are at the tip of the renal papilla again. Notice that several nephrons all share one collecting duct, just like several suburban houses may all have their individual sewage line, but when it gets to the road, they all share the final common sewage line. Can I go back over here for just a minute to get your bearings again? The nephron begins in the cortex, and proximal convoluted tubule, loop of Henle, distal convoluted tubule, collecting duct, which releases urine at the renal papilla. Now, an interesting thing for you to know is that the truth is only 10% of human nephrons go down deep into the pyramid, that is, into the renal medulla. The rest have very short loops of Henle, but only the ones with the long loops of Henle are able to give us a concentrated urine. And that's why we're concentrating on them.